Hello everyone, welcome to OdinSchool. Now, today in this class, we are going to learn about the very important module of any database concept, subqueries and joins. Without subqueries and joins, fetching a job in the world of data is going to be really tough. Not only fetching the job, in order to perform any simple tasks which revolves around taking data from several tables requires us to know about subqueries and joins. Without subqueries and joins, it becomes really tough for us to do any sort of data manipulation and data retrieval across tables. That is the idea today. We are going to learn about in detail subqueries and joins. First, let's understand why should we learn MySQL. MySQL is one of the market leader in terms of SQL service offered by any other company. It's a product of Oracle. And the best thing about MySQL is that it is open source, that anyone can download and start working on it with a lot of security in it. Not just that, in terms of the real world in the data industry, we all have challenges in accessing data, maintaining data, and performing any sort of manipulation over it. With that situation, it becomes really tough for us to work on any sort of data manipulation without a database concept. Now, learning MySQL will always help us in fetching a job in terms of working with huge amount of data, and also helps us in performing all data retrieval and data manipulation process. With that said, let me quickly introduce about OdinSchool as well as about myself. OdinSchool is a technology upskilling platform. We help you continuously acquire new skills. The motto of OdinSchool is that stay skilled and stay ahead. And myself, I'm Gautam Kumar Jayachandran. I have 6 years of experience as a senior data scientist, working in several technologies like Excel, SQL, Python, Tableau, Alteryx, and machine learning. I worked with several domains as well, like recruitment, retail, as well as finance. That with that said, let me quickly get into the content agenda for the today's class. The agenda for today's class is very simple. We are going to learn about subqueries. We are going to learn about different types of join, and we are going to learn about different types of subqueries as well. With that said, let me quickly get started with the content. Subqueries. What are subqueries? Subqueries are basically writing a query inside a query, like a nested query. That is what a subquery does. Now, talking about subqueries, theoretically a subquery is also called as an inner query or a nested query. Is a query within another SQL query that is embedded within the where or from clause. So basically, we will be able to write several queries, statements in several syntaxes of SQL statements, one within itself, through the help of where and from clause. Subqueries can be used to can be used with the select, insert, update, and delete statements, along with several arithmetic operators like equal to, not equal to, greater than, lesser than, and all the other parameters that we can generally use in terms of arithmetic expressions. Talking about the syntax, it basically takes the select statement and it takes the where condition, and inside the where condition we can actually take the help of another subquery. This is the theory part of it. Let me cover the practical portion of this particular subquery. I'm opening the same database that we used in the last couple of classes. So what I'm going to do is I'm going to select a table completely. Select everything from, let's see, a table. Let's pick Noble Win. Yeah, let's pick Noble Win. I'm executing it. It throws me all the values that are there in this particular table. So what a subquery can do is I can write one more condition here. Select year. Maybe I'll say select count of year. Here I wanted to have the maximum or rather what we can do is we can I'll give a simple example, then I'll give a complicated example. I'm just selecting everything from Novell Win. Here what I can do is if I wanted to understand Nobel Prize winners coming from a particular country, I can directly write a query. The same thing can be written using a subquery as well. I'll write where country is equal to Sweden. If I execute this, it gives me the winners from Sweden. See, the same thing can be written with the help of subqueries. So what I'll do is select year, or maybe I'll just simply select everything from Nobel Win instead of where directly if you go to country. What I'll do is where country is equal to select count of select country from Nobel Win where winner is equal to, let's see a winner and understand where this winner is coming from. Let me take Wolfgang Euler. So what I'll do is I'll write this condition. Okay, let me explain decode this first. So what am I trying to do here is this is the entire data set. Let's see the entire data set. Now in this data set I am subsetting the data only for the country Sweden. Now what am I doing is I am doing a subquery in the second place where I am writing one piece of select statement. Select everything from Nobel Win, and then I'm saying I wanted to apply a filter on country. Now if I wanted to apply a filter on country, the concept is that I can directly say what is the country that I wanted to filter, but assume I do not know what is the country of Wolf von Euler. Okay, he is from Sweden. Okay, but in this case, since I do not know, assuming that I do not know the country, what am I doing is I am picking country from Nobel Win, where winner is equal to this. So what this particular subquery will do is this particular subquery will extract the information, which is basically Sweden. The entire output of this would be equals to Sweden. Okay, this entire query will retrieve as a value which is Sweden. Then what happens is the output of this particular subquery will be supplied as input to the previous queries. So what happens in the backend is always the last query gets executed in the backend. So this Sweden will be supplied as input to the above query. Now what is the above query read? The above query will say select everything from Nobel Win where country is equal to Sweden. Since it's a string, it automatically figures out what is the value and gives us the output accordingly. Let me show you the output. Now if I execute this, the output that we are seeing here will remain the same. See here, we got the same output just as we got it from this place. But in this case, we know what is the country that we are looking out for. But assume in a data where we do not know a particular dimension, but we know some other dimension accordingly. So what we can do is we can write subqueries and then generate an output through which we can actually subset the data. This is how a subquery will work. Let me give a couple of more examples. Select country and year from Nobel Win, where year I wanted to know the latest year that is there in the data. So what I'll do is select max year from Nobel Win. So what this max year from Nobel Win will fetch us is 1994, which is the maximum year that we have in the table. Now this subquery will give us retrieve us 1994. So what happens with the machine now is the machine will retrieve the value for all the values that are equals to 1994. So if I execute this, it will say it will get the input from the last query, which is 1994. Then this output will be supplied as input to the previous query. Select country year from Nobel Win where year is equal to 1994. and this particular query will retrieve us the information about all the Nobel Prize winners in the year 1994. See here, we can also add winner, subject, and category. So here it gives me what what is the country, Germany, who won the award, Reinhard Selten, for what subject, economics, and then the category is economist. So it keeps giving you all the other information as we ask the machine to retrieve properly. So that brings us to the end of subqueries with where clause. So we use where clause, and using where clause we can retrieve several outputs. Assume I wanted to have, I will be having several outputs from my below query. Let me clean this. Now in all these cases, what we have done is we have retrieved only one output from the last query, from the second query basically. What if I wanted to retrieve multiple outputs? Now see what happens. Select everything from Nobel Win, where I would say category, what I can say, okay, category is equal to, okay, let me write one more query here. Select category from Nobel Win, where country is equal to Sweden. So what I am trying to do here is I wanted to see what under which and all categories Sweden has won a Nobel Prize. Now the problem here is there might be multiple categories under which Sweden might have won the award. If I execute this, it will throw an error because I'm using a equal to operator. It says subquery returned more than one value. So whenever we have more than one value, what we need to do is we should not go with equal to operator, which is basically a conditional operator. What I'll do here is rather I will just change this equal to into in. If I change this into in, what this in can do is it can accommodate several values that is generated out of the subqueries. So if I execute this, see here, Sweden has won award in several categories, and we have retrieved output for all those information. So looks like Sweden has won award only in scientist. Sorry, yeah, it has won award only in scientist. But in the first query, we have asked the machine to retrieve all the information belonging to the category scientist. That is why we have France, Sweden, Germany, US, and everything. But the category is predominantly only scientist because Sweden has won award only in scientist category. Let me show you that as well. So select everything from Nobel Win. Let's validate this where country is equal to Sweden. Let's see under what and all categories they have won awards. See here, they have retrieved only one award, one category, which is scientist. So what I can do is I can change for another country, USA. I'll check for USA and see if they have won for several categories. Looks like they have won for economist and scientist. Now what I'll do is instead of Sweden, I'll just change this into USA. If I execute this, see here we have both scientist and economist also. Let's group the data so that we will be able to see the output. Select our category in this. So what I wanted to do is I just wanted to group the data by category. Invalid character is contained in either aggregate or group by class. Okay. So okay, we have everything, right? Sorry, my bad. Year, winner, subject. I think that's it. Let's see if I'm missing any other column. Country. Okay, country is also missing. Okay. So if you see here, it is grouped by country, category, which is economist and scientist. So this is how you can use subqueries with where clause. Let's go on to the next topic. Subqueries using where. This is what we were seeing so far. So using the where clause, multiple operators can be brought into considerations while writing queries on multiple levels. Is exactly multiple operators I did not show. I'll give an example for multiple operators also. Now in this case we said we wanted to retrieve values for all the information about Nobel Prize winners in the maximum year, in the latest year. Now what I wanted to do is I wanted to convert this into anything less than or equal to the latest year. I don't want the latest year. Okay, if I just use less than, what it will do is it will give you values except the maximum year. What is the maximum year? 1994. So it will give me values less than 1994. Starting from 1970, it will give us the values till 1993. See, 1987 is the last year that we had till the maximum. The maximum here being 1994 being excluded here because we have written a query asking the machine to take values that are less than a particular value. So you can use any operator, not equal to, less than, equal to, all those operators and retrieve output out of it. Now talking about the next statements, we are talking about from statements. Talking about from statement in subqueries can be extracted from either var class or from statement. The from statement also works as a temporary table. It will not work as a permanent table. It works as a temporary table to supply out input to the previous query. Now what I can do is I'll give an example. Select everything from orders. To execute this, see here we have order number, purchase amount, order date, customer ID, and salesman ID. I wanted to retrieve data from the orders table only, but I don't want to have information on for a particular salesman. How can I restrict it? So rather than writing orders, what I'll do is select salesman ID, customer ID, and purchase amount. That is all I wanted to have. Okay, I can pick this from orders table. I can write a condition also where salesman underscore ID should be equals to 500 one looks multiple times occurring. Okay, that's all I'm doing here. Let me try executing this and see. It says invalid syntax near asterisk, so it says it cannot retrieve everything. Sorry, I think I made a mistake here. Yeah, invalid syntax near this. Have I made any mistakes? Select everything from select statement, salesman ID, customer ID from orders where salesman ID is this. Okay. Just using the brackets here. Um, I'm checking if there is any mistake that happened here. Nothing. Looks like there is no issue here. Let me execute this. It keeps saying the same thing. Select salesman ID, purchase amount from. Okay, let's see what happens in this case. Okay, I'll choose the columns rather than this. So what I'll do is I will choose customer ID from everything from orders. That is all I have to do. Let me check again. Keep saying the same thing. Looks like there is some basic issue here. Okay. Set customer ID from orders. Customer ID as items. Okay, so basically in this case it keeps throwing some error. But the idea behind select statement is that you can simply use a select from statement as an input to the previous query statement. Select, first let me see the data. Let me see what is the issue it is causing. select everything from Noble Win. Instead of selecting everything from Noble Win, what I'll do is I will select only the winner and category from Noble Win. That's all I'm trying to do. But it keeps throwing some error. Okay, there is this some syntax error that I'm making here. Maybe I'll give an example later, but the idea is very simple. We can use the subqueries written inside the select statements itself and then extract the output out of it. That is what a subquery does. Basically, rather than writing subqueries inside, outside from statement, we can use it from the where statement. Rather than that, we can also use the subqueries from the from statement as well. Okay, let's come to the most important topic, SQL joins. Talking about joins, the joins class is used to combine records of two or more tables in a database. As the theory suggests, it is as simple as joining or merging information that are contained in two different tables. That is what a join does. Let me give an example for all the four different joins that we are going to learn today. There are four different joins that we are going to learn. The first one is going to be the inner join. Then we are going to learn about left join. Then we will be learning about uh, right join, and then we will be also learning about cross join. So I'm just trying to create insights for all these cases. Let me show them one by one. The second join, and this is for the third join, and this is for the fourth one. So basically what happens in these cases is that inner join simply takes the information that are pertained in both the tables. If only it is present in both the tables, then I think I have to just change this size. Yeah, if I use this. So yeah, so the values that are corresponding only in both the tables, the intersection of A and B only will be written in inner join, whereas in a left join, the complete information from the left table will be retained, as well as the values that are belonging to the right table that matches the left table. The right table information will not be taken, but the values that are commonly present in both the left table and right table will be taken. The same happens with right table, right join, but the concept is it takes values that are present in both the tables. It will take the complete right table, but the values from the left table will not be taken completely. Only the matching values will be taken for merging the tables. Whereas in a cross join or a full join, what we will do is we will simply take all the values that are present in both the tables. There will be no restrictions whatsoever. So all the values, irrespective of the table, irrespective of the matching type, it gets joined with the joined together, and the output will be generated. Sorry for my bad diagram, but I'm just trying to explain the concept here. See here, this is going to be table A. Okay, this is table A and this is table B. So what happens with inner join is that it keeps values that are commonly present in both the tables. It will not take the entire left table, it will not take the entire right table. Whereas in a left join, it takes the entire left table as well as the values that are matching from the right table. Talking about right join does exactly the opposite of left join. It takes the entire value from the right table, also the values that are matching from the left table. Whereas a cross join is simply a join which takes all the values against each other in the other table. These are the four different joins that we are going to see today. Let me explain everything with examples. Cool. So talking about joins, whenever we have to have multiple tables combined together, we will use them. Now what I'm going to do is orders table. Yeah, we do have orders table. Let me show you two tables that are related to each other. And then I'll say select everything from salesman. So here I have salesman ID, I have name of the salesman, I have the city of the salesman, I have the commission for the salesman. Whereas in the orders table, I have salesman ID, but I don't have any salesman information. Assume I wanted to know which salesman has produced or performed this sales. I wanted to know the name of the salesman. I wanted to know the commission that he is going to get, and I wanted to know from which city is he operating. But all the information that I talked about is present in a different table. But we learned a concept called SQL constraints, where we learned about primary keys and foreign keys. As I told early, we can join we can join these two tables only if there is a common column that is present between them. The common column that is present between these two tables is salesman ID. So since we have salesman ID commonly present in both the tables, we can use this particular column as a foreign key and a primary key and join these tables and retrieve the required output. Now what I'll do is select everything from, okay, let's not select everything, let's select one by one. Select salesman underscore ID, a dot select salesman underscore ID as salesman ID. Then what I'll choose is I will choose a dot name as salesman name, comma, let me choose a city also, a dot city as salesman city. Then I will talk about orders in, okay, I also wanted the commission, so I'll write a dot commission as salesman commission. Then let me see what and all columns that I wanted from the orders table. I wanted to know the purchase amount, b dot purch underscore amount as sales amount, and we wanted to know to which customer he has sold it. So I'll write b dot cust underscore customer ID. Okay, customer ID. I'll choose this as customer ID. Then I think that's pretty much is what we wanted to know. Let's not have information about the date they sold things and the order number. I don't want all those information. Now, if you see the select statement, what I have done in the select statement is that I have picked columns from both the tables. From the salesman table, I have picked the salesman ID. From the customer table, I have picked purchase amount as well. So what I should do now is I have to join these two tables. Only then the select statement will be able to retrieve all the information. To distinguish between both the tables, what I have done is I have given a temporary renaming to all the tables. So A table will be salesman table, B table will be customer table. So what I'll do is I'll say this to the machine, from salesman A, or I can say salesman as A. So what happens is salesman table will be renamed as a table, table A. What I'll do is I will ask the machine to perform inner join orders table, which is a B table, right? From salesman as A, I don't have to use ASCII here because directly machine can understand that salesman is given as A and orders is given as B. Okay, inner join orders B, where A dot salesman ID is equal to B dot salesman ID. So in this case, why am I using where statement is that it basically, excuse me, it basically takes information that are present only in both the tables on the bridge of salesman ID. Since there are no any other common columns, we have to use a common column to fetch the information rightfully. Let's execute this. Invalid syntax near key. Okay, inner join orders B. Sorry, I can use on, my bad. I can use on rather than using on as a where. I have to use on here. If I use on, see what happens. It gives me the salesman ID, salesman's name, salesman's city, salesman's commission, and the sales amount, and the customer ID to which we have sold it. So salesman ID 5002 belongs to Nail Knight. He is from the city Paris. His commission is 0.13 and his sales amount is this. And the customer ID is 03005. So what happens in this case is he will be given a value of a commission which is 13 percentage of the overall sales amount is his commission. Since I don't have purchase amount as integers or numbers, I'll not be able to perform manipulation. Let me try changing the data type so I can show you one data manipulation also. This is coming from our table orders. So right click orders. If I wanted to change the data type, if you have enough rights, it will let you to change it. If you are not the administrator of the machine, it will not let you do changes. I'm just trying to change the data type here. In design, I have purchase amount. See here, the purchase amount is in the as of the data type variable character. What I'll do is I will change this into not integer. Let's keep decimal places. But I wanted to have 2 decimal points in this, and then I can close this. See what happens. It says saving changes is not permitted because I don't have administrator access here. So but yeah, you can change the data type here, and then you can perform data manipulation also. You can calculate what is the commission that he might have got for this particular sales, which is basically sales amount into salesman's commission will give you the overall commission that they might have generated using a particular operation. So this is how inner join works. Now inner join will not retrieve as values if it is not commonly present in both the tables. Now let's see how many distinct salesman information is there in both these tables. Select distinct salesman underscore ID from salesman 5012345667. Let's see what are all salesman ID that we have in orders table and compare it together. We have all the information, so the output will retrieve us all the information that we wanted to have in as output. Now what I'll do is I will change the uh, uh, what is this? I will change the salesman information in the orders table so that we can see a difference in the output. I wanted to change 5007 as 5008. I'll just update the data here. 5007. In that case, my salesman table will have 5007, but my orders table will not have 5007. So hence, in select statement, you will not be able to, sorry, in inner join, you will not be able to see 5007 as output. See here, we have 1, 2, 3, 5, 6, 8. Let's see what happens in salesman table. In salesman table, we have 1, 2, 3, 5, 6, 7. So this 7 is not present in orders table. Let's execute the query one more time, the inner join query. If I execute this, there will be no 5007. We can also group the data. Yes, let's group the data. Group the data by salesman ID. Since I'm not doing any aggregation, I hope it should work. I should say which salesman ID. So I'll say a.salesman ID and execute this. We have all the other information also that has to be grouped. So I'll just change a.name, a.city, and b.purchase amount, and b.customer ID, a.commission. Now it should work properly. Let me execute this and show you the output. See here, we have 5001, we have 5002, we have 5003, we have 5005 and 5006. 5007, which is present in the salesman ID in the salesman table, is not present in the output of inner join, because the concept of inner join is that it will retrieve values that are commonly present in both the tables that we are trying to join. In this case, we tried joining salesman table and customer table, where we have only 5001, 2, 3, 5 and 6. We do not have 6. Inner join can be written directly as join also. The normal join also works as proper inner join only. When I execute this, there will be no change in the output. The output will remain the same. This is about inner join. First thing, this is about inner join. Let's talk about left join. Left join, as I told you, it returns all the rows from the left table on the left, even if there are no matches on the in the table on the right. This means that if on the on class 0 records in the right table, the join will still return a row in the result, but with a null in each column from the right table. Theoretically, what does it mean is, even though there is no match in the right table, for all those line items in the left table, it will fetch us nulls appropriately. Maybe I'll show you the example here. Here, instead of inner join, all I'm going to do is perform a left join. If I perform a left join, my output here will have 5008, but from the orders table, I will not have any information. What are the information that we are getting from orders table? Let me close this. From the orders table, we are getting purchase amount and customer ID, right? So see what happens when I perform a left join. All this information will not be returned. For sales amount and customer ID, there will be nulls. Let me execute this piece of code. See here we have 12 rows now. We had 11 rows in inner join. We have 12 rows now. We have 5007, which is coming from the left table, which is the salesman information, salesman table, where, as I told you, there will be no values for the sales amount as well as the customer ID, because there is no match to the right table. This is the default property of a left join. Okay. So let me give another example. Let me write a completely new example. Done. Okay, let's take one more table. Let me see what do we have in customers table. We have customer ID, we have customer name, we have city, grade, and salesman ID. Beautiful. So what I'll do is I'll check how many distinct customers are present in customer table. We have 8. So what I'll do is I will check the same thing from orders table also. In orders table also we have customer ID. So I'll check customer underscore ID from orders. Here also we have 8. So what am I going to do is I'm going to write an update query to change the values in orders table. So update orders, set customer ID is equal to 3003010, where customer ID is 3009. Two rows got affected. Now let me just delete this. So here we have 8 rows, but we have 3010, which is not present in customers table. Let's see this. Here there is no 3010 in customers table. So using this concept, what we can do is we can try understanding left join one more time. I wanted to return. Let me show you the data. In customers table, I have customer information, customer name, city, grade, and salesman ID. I wanted to return everything from both the tables, from both customer table as well as orders table. So what I'll do is select everything from customers A, left join orders B. On A dot customer ID is equal to B dot customer ID. So what happens is this particular join will retrieve us the columns from both the tables completely. It will not pick one column or second column. It will give you entire value. So here customer ID, customer name, city, grade, and salesman ID from the customer table, order number, purchase amount, order date, customer ID, and salesman ID from the customer orders table. Now to distinguish this, let me draw a line. Maybe I'll increase the size a little. So basically everything that is coming from this side belongs to table A, which is the customer table. Anything that comes from this side will come from the right table, orders table. This is from the right orders table, and this is from the, see here, the entire content here is from the orders table. The entire content here comes from the customer table. This is how a left join works. So in this case, what happens is it has retrieved as output that are basically part of, excuse me, Yeah, so what happens in this case is it basically has returned as values for all the customers, but we do not have values for 3010. If you see here, there is a lot of null in this particular orders table, because there is no such match in orders table. There is no such customer called 3009 in it. That is why it has retrieved as the values. But here if you see the orders table, in orders table we don't have 3010, the value that we manipulated, because we are performing left join. It will focus only on the table that are from the left side. Basically the table that I specify first becomes my left table, and the table that I specify next becomes my right table, right? So in this case, it has retrieved as only 3007 and 9 and things. There is no 3010, which is part of the right table. Since there is no match, it has retrieved as null in almost all the cases. This is how a left join works. Right, perfect. Let's go on to the next one. Right join. A right join returns all rows from the right table, though there are no matches in the left table. As we have already seen, a right join performs exactly the same thing opposite to what left join does. A left join simply returns all the values from the left table and matching values from the right table, whereas a right table retrieves all the values from the right table and the values that are matching from the left table. Let me give a couple of examples for this. Let me delete everything. So I wanted to select from customers, and I wanted to select from orders. There will be two output now. One is for customers, another one is for sale orders. We have order number, purchase amount, order ID, customer ID, and salesman ID. Now I wanted to perform a right join out of it. Now let me show you how does it work. Select a dot customer underscore ID as customer ID. Then I will choose customer name a dot as customer name. Then I will choose the city that they are corresponding from as customer city, and the grade that they own. Customer's grade, and let me take values from the second table, which is b dot order number. What is the order number of the sales as order number? Then b dot purchase underscore amount as purchase amount. Then b dot order date. These are the information that we want. So I'll say order date. From all these selections has to come from customers tables first. Customers table will be my A table. I will first show you what does a left join does. Left join orders B on, what's the column? So on A dot customer underscore ID, on B dot customer underscore ID, and I wanted to group the, I'll say order the data by A dot customer ID. This is enough. Yeah, this should be fine. So see here, what it has done is it has basically retrieved data from the left table, which is customers table in this case. Let me give one more example to this. Yeah. So see here, customers tables is the left table. Orders table that we are using here is the right table. So from the left table, it has picked all the customer ID 301, 2, 3, 4, 5, 7, 8 and 9. There is no 10 because there is no match to the match in the right table. See what happens when I simply do the same thing in terms of a right join. I'll just change this left to right. You will see a change that here you will have values. Let me color this so that we can identify it later. You will have values here. Various in this case 3009 won't be appearing. 3009 will have nulls as it is. Let me show you the outputs. Executing this. See here it generated values. See here for the order number, purchase amount and order date coming from order table, there are two instances of 3010. So there are two nulls in our table, in our left table, but the other things gets executed. 3001, 2, 3, 4, 5, 6, 7, 8. There is no 3009 in this case because 3009 is not present in the orders table. Since we are performing a right join, there will be no nulls in the right table. There will be nulls in the left table. If we are performing the same thing in left join, there will be no nulls in the left table, but there will be nulls in the right table. This is the key difference between left join and right join. See here, does perform left join and right join. That brings us to the end of right join. Let's talk about cross join. Cross join is basically a Cartesian product. When I say Cartesian product, it is very simple. What it will do is, if there are 5 rows in table A, if there are 5 rows in table B, what it will simply do is it will multiply each row with every other row in the second table. So 1 into 5, 2 into 5, 3 into 5, 4 into 5 and 5 into 5, finally giving us 25 line items. Now let me show you with an example. Let me edit everything, select everything from customers and select everything from salesman also. Now if I wanted to know the count of this, so select count everything from say customers. The same thing I'll apply and see how many line items are there in both these tables. So let me execute this first. So there are 8 line items in customers table and there are 6 line items in salesman table. The good thing about customers cross join is that the best thing about cross join is that you don't have to have common column that are present in both these tables. Without a common column, you can still perform a cross join because it is not going to see whether the values are matching in both these tables, irrespective of the match or whether they are matched or do not. They are going to retrieve values in all the cases. Now see, 8 into 6 should be 48 line items for us. So what I'll do is select everything from customers table, cross join salesman table. Since we do not require any common column, I don't even have to specify on a dot customer id and b dot customer id. I don't have to do anything. Just ask the machine to perform a cross join, which will retrieve us 48 rows. See here, exactly 48 rows we have. So for each line item, there will be one multiplication. See here, what it has done is the customer table. Let me show you here. See here, the customer table has considered the first sales representative in the salesman table. So there are 8 line items in the customers table starting from 3001 to 3009. It has taken all the values and tried matching it with the salesman information that is present in the second table. So basically, as I told you, it does not really matter whether there is a match between these two tables or not. It will take all the values from one table and multiply with each and every line item in the second table. That is what we are seeing here as an output for cross join. Yeah. Now we can also use cross join with a inner join only. So what I'll do is select customers and salesman. This is another way of performing cross join. If I directly say select everything from customers and salesman, it will still produce me the same result, 48 rows here. There is no change in the output. The output will remain the same. It performs, if I ask the machine to retrieve data from two tables without any conditions to it, it directly performs a cross join for me. As I told you, we can use cross join as a inner join also. Select everything from customers A, cross join salesman B, where A dot salesman ID is equal to B dot salesman ID. So in this case, what happens is it will try to identify the salesman IDs that are present in both the tables. Only if there is a match, it will retrieve as the values. See here, it has produced only 8 rows in this particular case. It has said us that for the customer 3002, whose name is Nick Rimando, the salesman who's working is James Hoog, and he is from the city New York. The customer is also from the city New York. The commission that he gets for working for Nick Remendo is 0.5. Here also we can subset the data like if only the customers and salesmen are coming from the same city, and I'll say A dot city is equal to B dot city. In this case, James Hook will this particular line item gets returned because the city is same here. Second line will not come. Third line will be retrieved because the customer and the salesman coming from the same city. Fourth line, fifth line all have same cities, but all three will not come. So we should have only 4 line items in this case. Here there are only 4 line items. The customer Nick Rimando comes from the same city as the salesman James Hoog. Brad Goosen and Peter Lux comes from the same city. Fabian Jones and McLean comes from the same city. Brad Davies and James Hoog also comes from the same city. So this is how we can play with joins. Limit statement is something that we have already seen, so I'm directly going to come to the recap session of this entire class. We have learned about subqueries, we have learned about joins, and we have learned about types of subqueries and joins. Subqueries are basically queries written inside each other. I can write 3 subqueries, 4 subqueries with each other. There will be no disturbance in terms of output. The output will remain the same. Talking about joins, there are 4 different types of joins: inner join, left join, right join, and cross join. We can also perform full join. Let me also show you full join. But in MySQL, there is no concept of full join directly. So what we will do is we will let me select columns from both these tables. So A dot customer ID as customer ID, then A dot customer name as customer name. Then we want let's keep salesman ID also here. So B dot salesman underscore ID as salesman and salesman ID. Then we have customer name. Then let's have customer salesman name. So B dot name. Okay, B dot name as B dot name as salesman name. And what else do we wanted to see? I wanted to see the grade and commission. So I'll say A dot grade as uh, customer grade, and then we have A dot commission as B dot commission, because commission belongs to salesman table. So B dot commission as salesman. Okay, so in these cases we have salesman and customer information in both the tables, but we don't want to retrieve values that are not only present in both the tables. There should be one value missing in the salesman table, one value should be missing in customers table. So what I'm going to do is again write an update query, update salesman table. I wanted to change the salesman ID is equal to 50 5006 should be changed into 5009, where salesman ID is equal to 5005. One row got affected, so there was one salesman with a salesman ID of 5005. Now what I'll do is I'll perform a left join. First have to retrieve all this from customers A, left join salesman B on A dot salesman underscore ID is equal to B dot salesman underscore ID. This is the common column. This is what a left join performs, right? So what I'll simply do is union everything with a right join. So there is no concept of full join directly. So what we will do is we will merge two queries to generate an output out of it. We will merge both left join and right join. That way all the information will be retrieved in both the cases. Let me perform bracketing here and then finally close it here. So in this case, let me zoom this a little, zoom out a little. Yeah, if I come here. So what am I going to do is I'm going to just reduce the size of it. Yeah, that way we can see the entire query. If I simply execute this piece of code, it says invalid syntax near A. So from customers, okay, there is no comma that I've given here. So I'll just change this comma. Here also I'll just add a comma. That's all I need to do. The query looks good. See here, it has performed a full join for us. Even though we have changed the value in the salesman table, now since we are performing a full join, what it will do is it will give us the values irrespective of whether it is present in left table or not. In left table, we do not have the salesman information, which is 5009. See here, which is not there, but even then we were able to pull the data from the customer table by writing a right join. So it has performed both the left join and right join. That's why in both the left table as well as in the right table we have nulls, and it has combined together to generate an output for us. So this is how we can perform a full join. Cross join and full join are completely different from each other. In types of subqueries, we learned about subqueries that we can retrieve from where statements. So that brings us to the end of this particular class. Thank you so much for joining today in this class. Don't forget to like, share and subscribe for the OdinSchool YouTube channel. Thank you so much once again for